This is what's called a initial value problem. Okay, so we have an initial value. So when x is 0, y is -4. Y is -4. So this is initial value or initial conditions. Now, it's a problem. Initial value problem. The problem is solve for y. So, in short, initial value problem. Initial value problem is a differential equation plus initial value, or sometimes there'll be some more information. So, initial value problem is a differential equation together with some, initial value or in general data. So, we're going to solve by separation. This one's a little bit tricky. I need to factor. Need to factor first. So what does that require? Because it's not going to be separable. I got this plus down here, which is a trouble. But I can deal with it by factoring that denominator. And now it's separable. Okay, again, separable means I can bring my y's over here, my x is over here, x is over here, using only the operations of multiplication and division. So if I multiply both sides by y, I get y dy over here. And if I multiply both sides by dx, I get x over x squared plus 1 dx. All right, separate. And the next step is integrate. Integrate there. What does that give? It gives y squared over 2 is equal to. So here, I'm not going to show my work. I would do substitution. U is equal to x squared plus 1. And I'm going to get a half ln x squared plus 1. I'm going to drop my absolute values because x squared plus 1 is positive. Positive number or non-negative number plus 1. So just put old-fashioned brackets there. And what? So straight away I got division by 2 on both sides. So I will just go y squared is equal to ln x squared plus 1. I could put 2c, but I'll just change it to a k. So k is equal to 2c. Doesn't really matter as long as I don't get mixed up with what my constants are. Okay, the main thing is with the constants is that as soon as you're done integrating, okay, when the integral signs disappear, the constant has to appear right here immediately. Okay, a common mistake is to forget to put it here, do a few steps, and then throw in the plus c later on. That's not going to work. Okay, plus c appears as soon as the integral signs disappear. Okay, where was I? At this point I would like to find k. Okay, I don't want to solve any further before finding k. Okay, k is very available right now. Okay, so I should use my initial conditions and find k. So when x is 0, y is -4. So I get, so using this, plugging that in here, I get 16 is equal to 0, right? Yeah, that's going to be 0 plus k, so k is 16. And where does that bring us? Brings us back here, but with a 16. Now, if I can solve for y, I should. So I certainly can solve for y here. So the operation I'm doing to solve for y here is I'm doing a square root of both sides. So let's just do that explicitly. Make sure you extend this all the way. Now, what do you get when you have absolute value? Skipping steps. What do you get when you square root y squared? Well, you get absolute value of y is equal to so that means that y is equal to plus or minus. Okay, so we end up with this plus or minus here. Okay, most of you probably knew that, okay, when you have something squared equals something and you solve, you should put a plus or minus here. But you may have not seen, you know, all these reasons why the plus or minus appears. Are we done? Not quite. We can actually choose. And we must choose the plus or the minus, right? There are two functions given here, but we know that when x is 0, y is negative 4. So say, but y of 0 is negative 4. Okay, negative. So that means we have to take the negative. Last night I said these words to my love. Dum, 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 dum. You know you never even tried love. Come on, dum, 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 come on, dum, dum. Come on, dum, 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 come on, dum, dum. Please, 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 please me. I gotta please you. Beep, 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 beep. Dum, 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 dum. Dee, 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 do, dee, 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 dee. Come on, boom, boom. Come on, come on, come on. Please, please me. I gotta please you.